everyone. I'm Teacher Zhao Wei. Today we will study Project 3, Fundamentals of Stamping and Forming, Part 2 of the Advanced Manufacturing Technologies for Welded Structures course. In manufacturing, stamping and forming is a highly efficient and precise processing method, widely used in industries such as automotive parts and appliance casings. First, let's get to know the key piece of stamping equipment, the press. The press is one of the three essential elements of stamping. Its classifications are numerous. As shown in this table, presses are categorized by name into mechanical presses, hydraulic presses, automatic presses, etc., with corresponding codes J, Y, Z, and so on. Different types of presses have distinct characteristics and suitable applications. For example, the open crank press is a type of mechanical press. Hydraulic presses also come in a variety of typical structures, such as the 3-beam 4-column design and the twin-column pull-down design. Hydraulic presses can be further divided into oil presses and water presses. A press's model designation consists of pinion letters, English letters, and numbers. Each segment has a specific meaning. Remembering these rules will allow you to quickly grasp a press's basic information from its model number in practice. When selecting stamping equipment, you must determine the right press based on the specific stamping requirements. For deep drawing parts, if they're large, we typically choose an updrive, closed die, double action deep drawing press. For medium and small deep drawing parts, we use a bottom drive, double action press. This is because a closed die, double action press offers reliable blank holder force and a simple die structure, making it ideal for mass production. For small batch, thick material stamp parts, hydraulic presses are often used. Their adjustable die closing stroke suits high-force stamping without overloading due to thickness variations in the sheet. However, hydraulic presses work more slowly and have lower efficiency. For precision piercing parts, it is best to use a dedicated precision piercing press. Otherwise, a standard crank press or hydraulic press with high accuracy and rigidity must be fitted with a blank holder and back pressure system before performing precision piercing. There are several important parameters of a press you need to master. Nominal, rated, tonnage is the maximum allowable working pressure on the slide when it is a certain distance above the bottom dead center, around a 30 degrees crank angle. When selecting a press, ensure that the stamping process force curve remains below the allowable load curve. Slide stroke refers to the distance the slide travels from top dead center to bottom dead center. The stroke must be sufficient to allow for loading the blank or semi-finished part and unloading the formed part. For deep drawing, the press stroke should be at least 2.5 times the finished part's height. The shut height is the distance from a slide's bottom plane to the work table when the slide is at bottom dead center. You adjust shut height by changing the length of the press's connecting links. When the connecting links are set to their highest position, the shut height reaches its maximum value, known as the maximum shut height. Additionally, the work table's dimensions must exceed the lower die's dimensions with room for fastening. The work table hole size must be smaller than the die's scrap fall hole or the ejector pin diameter. The die shank hole must match the diameter of the slide's die shank mounting hole, and the shank's height must be less than the hole depth. With the development of manufacturing, stamping production automation has become an inevitable trend. Automated stamping production is an effective and essential method for improving labor productivity and enhancing working conditions. As the quality of automotive and electrical products in our country continues to rise and production scales expand, achieving automation in the metal stamping industry has become an inevitable necessity. Compared to traditional manual methods, automated production offers many advantages. It stabilizes product quality, reduces labor intensity, ensures safety, and greatly improves efficiency. Common automated production methods include manipulator systems and robotic production lines. Manipulators and robots differ significantly in installation, usage characteristics, production rhythm, and investment cost. Robotic lines are more economical and widely applicable, while manipulator lines are better suited for large gap press lines and retrofitting existing lines. Next, let's explore the types of stamping dies. A blanking/punching die separates material along a closed or open contour line. Examples include blanking dies, piercing dies, cut-off dies, slotting dies, trimming dies, and slitting dies. A bending die induces linear, bend line, deformation in sheet blanks or other workpieces to produce parts with specific angles and shapes. A drawing die forms sheet blanks into open-bottom hollow parts or further alters the shape and dimensions of hollow parts. Common processes in metal parts manufacturing. A forming die directly reproduces the convex and concave shapes of the die on the blank or semi-finished part, causing only localized plastic deformation of the material. A riveting die uses external force to join or overlap parts in a prescribed sequence and manner to form a single assembly. A single operation die completes only one stamping operation in one press stroke, one of the most common die types in metalworking. A compound die has only one workstation and is capable of performing two or more stamping operations simultaneously at the same station during a single stroke of the press. A progressive die features two or more workstations arranged along the feeding direction of the blank. It completes multiple stamping operations sequentially during a single stroke of the press. A transfer die combines features of single operation and progressive dies, using a manipulator transfer system to boost efficiency, reduce cost, save material, and ensure reliable quality. Finally, let's discuss quality inspection, which is vital in stamping production. Quality inspection involves evaluating stamped parts for conformance and classifying defective parts for appropriate handling. It is the key to ensuring stable product quality and promptly identifying and resolving issues. Inspection criteria should be defined according to product requirements. For parts without special requirements, industry standard apply. This ensures every part meets the standard for comprehensive quality control. Now, let's examine a task case. We need to use a stamping robot to form the main panel shown in the diagram. The developed shape and dimensions are provided in the figure. This task integrates much of today's learning, choosing the right press and die, followed by quality inspection. Each step is critical. After class, please consider how you would execute this task yourself. That concludes today's lesson. I hope this explanation helps you gain a deeper understanding of stamping and forming technology. In practice, we must select appropriate stamping equipment and dies based on specific needs, develop sound stamping processes and operating procedures, and strengthen quality inspection to ensure product quality and production efficiency. This lesson is concluded. Thank you for listening. Goodbye.